Okay, ma. So in thermodynamics, we studied work by using graphs, no ma? By using indicator diagrams. We have calculated how to calculate work done. No? Now we are studying about the first law of thermodynamics. No? Very good. ఇంకొంచెం పైకి అండి, ఇక్కడ నుంచి వేస్తే కానీ ఇంకొంచెం సౌండ్ వస్తుంది. సో బ్యాక్గ్రౌండ్ మ్యూజిక్ ఉండాలి అట్లా. ఓకే సీమా. సో కన్సిడర్ దిస్ ఈజ్ a cylinder in which gas is present. Clear? So this gas, we are heating this gas. Okay, ma? So what is meant by heating? Giving heat energy to the system, no? Okay, ma? Supplying heat energy to the system is called as heating the system. So it means Q. Q is nothing but heat energy. Are you able to understand, ma? And here I will write the sign conventions also. So for example, if I write a plus Q, a plus Q indicates that heat is given to the system. Heat is given to the system. Are you able to understand? And the same sign convention we will use in chemistry also. I am comparing both of them. Clear? Because anything given to the system is taken positive in chemistry. Here also it is positive. Plus Q indicates heat is given to the system. Minus Q indicates heat is taken out of the system. Heat is taken out of system. Okay, ma? And in chemistry also we will use the same sign convention. If anything is taken out of the system, then we consider it to be negative. So here also heat given to the system is positive, heat taken out of the system is taken negative. Clear now? Then this amount of heat energy which you are supplying, it will do two things, ma. Clear? So first of all, it will raise the temperature of the gas, and the second one is it will move the piston upwards. So it will do two things, no? So we will make a note of that. So heat supplied will do two things, or two works also you can say. First one is it rises. RIS, you know, it rises temperature of gas. Okay, ma? So if temperature of the gas is increasing, we say internal energy will increase, no ma? Internal energy depends on what? In thermodynamics of chemistry we studied, no? Internal energy depends only on temperature. So if temperature is rising, it means internal energy is increasing. So therefore I will write delta U is positive. What is delta U? Change in internal energy is positive. It means it is increasing. Are you able to understand? And the second thing is, this gas will move the piston upwards. If it is a movable piston. If it is not movable piston, then piston cannot move upwards. But if it is a movable piston, piston also moves upwards. Are you able to understand? So therefore the amount of heat energy which you are supplying, it will do two things. Some of the energy is converted into internal energy, and some of the energy will be utilized to lift the piston upwards. Are you able to understand? So if you observe this one carefully, this is again according to law of conservation of energy only, no? What is law of conservation of energy? Energy cannot be created, it cannot be destroyed. Just you can convert this one from one form to another form. This is satisfied here also, no ma? Clear, no? So for example, if I consider Q to be 10 joules of energy we are supplying. Okay, ma? Then change in internal energy is 4 joules. Clear, no ma? And work done by the gas is 6 joules. I can write like this, no? You are supplying totally how much energy? 10 joules. But out of that, what is the increase in internal energy? 4 joules. And what is the work done by the gas? 6 joules. So 10 is equals to 4 plus 6 only, no? So therefore the first law of thermodynamics says that Q is equals to delta U plus delta W. This equation is nothing but the first law of thermodynamics in the case of physics. Are you able to understand? But in the case of chemistry, how we have written, do you remember, ma? Delta U is equals to Q plus delta W. This is how we have written in the case of chemistry in thermodynamics. Okay? Because in chemistry, how we define? So if internal energy increases, then everything will become positive. We take the increase of internal energy to be our reference. Okay, ma? So if Q is responsible for increasing internal energy, then Q is positive. Delta W is responsible for increasing the internal energy, then delta W is positive. That is the reference we take in chemistry. Internal energy పెరగాలన్నమాట. ఇంటర్నల్ ఎనర్జీకి పెరగడానికి ఏదైతే యూజ్ అవుతుందో అదంతా పాజిటివ్ కెమిస్ట్రీలో. బట్ హియర్ we solve according to law of conservation of energy. Okay, the amount of heat energy which you supply, so it will do two things. It will raise the internal energy and work may be done on the piston also. Are you able to understand? Now delta U is positive. It means what? Delta U is positive indicates temperature is increasing. That is the meaning of this one number. Delta U is positive means internal energy is increasing. If internal energy increases, it means temperature is also increasing, first point. Similarly, if delta U is negative, then it means the temperature of the gas is decreasing. So these are the sign conventions. These sign conventions you should remember very, very carefully. Are you able to understand? Similarly, delta W is positive. Work done by the gas. What is meant by delta W here? Work done by the gas. Okay, ma? So work done by the gas, if it positive, it means that the system should expand, no? It means system should expand, because already we have studied in the first class, no? For example, if this is the piston, are you able to understand? Gas will apply force in this direction. Piston also moves in the same direction. Then system will expand. Clear, no? So angle between force and displacement is 0 degrees. So work done is positive. Understood, no? So work done is positive indicates that system expands. System expands. Or you say volume of the gas increases. Okay. Similarly, work done by the gas, if it is negative, then what is the meaning of this one? It means that system compresses. It means volume of the gas reduces. Is it clear? But this value is taken exactly opposite in chemistry. If W is positive, it means gas is compressing. Do you remember? If work done is positive in the case of chemistry, it means system of the gas is compressed. Are you able to understand? Or volume of the gas is compressed. Why? If volume reduces, then only internal energy increases. You are doing some work to compress the gas, no? That work done converts into heat energy of the gas. So if you are compressing the gas, heat energy increases, no? Or internal energy increases, no? Then that work done is taken positive in chemistry. Are you able to understand? Whatever is done to increase internal energy, that is taken positive in chemistry. But here, we are studying a different concept. The amount of heat which you supply, it will do two things. So first of all, it can change internal energy. Some work can be done by the system also. Are you able to understand more? So this is called as first law of thermodynamics according to physics. Are you able to understand more? So therefore, Q may be positive, Q may be negative. Delta U may be positive, delta U may be negative. Work done by the gas can be positive, work done by the gas can be negative. Anything can happen. Are you able to understand? Come on, make a note. And here Q and delta W, they are path functions. That also we have discussed. No? Q and delta W, they depend on the path in which we are traveling. Okay? If you are traveling in a different path, then Q and delta W also may be different. But delta U depends on what? It depends only on initial point and final point. It is a point function. Point means depends only on initial point and final point. It doesn't depend upon the path in which you are traveling. Are you able to understand? See, for example, if I draw a system here, okay, this is PV graph, okay. So this is my initial state, P1, V1. This is my final state, P2, V2. To this state, I can travel like this also, I can travel like this also, I can travel like this also. That's all, no? So there are three different processes in which I can move. And in each process, Q and delta W will be different. Are you able to understand? Q and delta W, they are different. Why? Path is different, no? Path is different. But in all the three processes, delta U remains same. Why delta U remains same? Because initial points and final points, they are same, no? Change in internal energy always remains constant. Understood? Make a note. So therefore, in this diagram only, you can define. Okay, ma? So in these three processes, Q delta W will be different. Because they are what kind of functions? Because they are path functions. Okay, ma? And but in all the three processes, okay, ma? So which one is same? Delta U remains same. Delta U remains same. Why? Because it is a point function. Okay. So because it is what kind of function? It is a point function. That is the point which you should remember. Clear, no? So this is about first law of thermodynamics. Is it clear, no? And all the sign conventions we have written, no? Sign conventions of heat, sign conventions of internal energy, sign conventions of work done. Okay. Plus Q indicates heat is given to the system. Plus U indicates temperature of the system is increasing. Okay. That is internal energy is increasing. Delta W indicates system is expanding. That is the sign conventions which you should remember. Okay. Make a note. Okay. So let us see this question. So we are performing some processes on this system of gas. First of all, we are moving from A to B. This is one process. Another process from B to C, C to D, and finally from D to A. So these are the 4 different processes we have performed on the same system. Now when I look at this, definitely this is a cyclic process. Why it is a cyclic process? Because I have started from A and I have again reached to point A itself. So definitely this is a cyclic process. So first point which I can write is, this is what kind of process? This is a cyclic process. Clear, no? Because starting point is A, ending point is also A only. Now determine the internal energy in a state C. So here I want to find out the internal energy. Okay, ma? So system has internal energy. How much internal energy? System has internal energy of 400 millijoules. That we forgot. 400 millijoules in state C. That is the internal energy. Okay, ma? So it means that U at a point C is how much? U at a point C is 400 millijoules. This is the internal energy at point C. Okay, ma? So determine internal energy of the system at a state B. Okay, ma? So here at internal energy at a state B I want to calculate. Clear? So if heat given to the system during the process from B to C will be 50 millijoules. Okay. So Q is equals to how much? Q is equals to 50 millijoules. So Q given, it means Q is a plus 50 millijoules. No? Why I am writing Q is equals to plus 50 millijoules? No? Because heat is given to the system. Given means we have to take positive value. Clear? So internal energy at point C is already given. I want to calculate internal energy at point B. This is the first question. Are you able to understand? Now anybody, can you say how can I do this calculation? Internal energy at point C is given. Internal energy at point B I want to find out. Heat supplied to the system is given. How can I do this calculation? Q is equals to delta U plus delta W. Delta W, how can I calculate? Which formula is there for work done? Integration. But I don't have any pressure equation here. How can I do? Sima? So by using first law of thermodynamics, I can write what I can write. I can write Q is equals to delta U plus delta W. This is how I can write, Nama. So therefore, what is Q here? Q is nothing but 50 plus 50. So delta U is nothing but which process we are doing? From B to C. We are moving from B to C, no? So internal energy I can write UC minus UB. This is how I have to write, no? Change in internal energy means final internal energy minus initial internal energy. Final internal energy is nothing but internal energy at C. Initial means at B. Okay? So UC minus UB plus delta W. This is how I have to write. Clear, no? Now delta W is how much? How can I calculate delta W? If I know delta W, definitely I calculate internal energy at B. How can I calculate? Sima, here this is PV graph only, no? What kind of graph is this? PV graph. So area under a particular graph will give work done. Already we have studied, no? So what is the equation for work done? P into delta V, no? This is of which format? Area is equals to length into breadth format only, no? So area under PV graph will give what? Work done. That's all, no? So which is the process we are studying? We are studying the process B to C. Clear, no? It means this is B and this is C. So this area under BC graph, this will give the work done. Already we studied in the last class, no? Now see. Now first of all, is it expansion or is it compression? Expansion. We are moving from B to C. This is the process. We are moving from higher volume to lower volume. Compression or expansion? Compression. Compression means positive work done or negative work done? Negative work done. So how much will be the negative work done in this condition? Clear, Nama? So delta W is negative of, what is the pressure value? Pressure is 2 atmosphere, 2 Pascal, 2 multiplied by volume. Change in volume is how much? 70 minus 20. Final volume is, final volume is 20. Initial volume is 70. What is the change in volume? Change in volume is 50. So 50 multiplied by, but here it is given in liters, Nama. Liter is not the SI unit. Which is the SI unit of volume? Meter cube. Meter cube. 1 liter is equals to 10 power minus 3 meter cube. Okay. See here how many liters are there? 50. 50 multiplied by 10 power minus 3. Are you able to understand, Amma? So therefore, delta W is how much? Delta W is nothing but minus 100 multiplied by 10 power minus 3. Or I can write minus 100 millijoules. Okay. So this is the amount of work done by the gas. Are you able to understand? Now take this value and substitute here. So substituting in the first equation, I will get to 50 is equals to, so internal energy at a point C, I don't know, no? I know, this is 400 minus internal energy at point B, I don't know. And what is the work done, ma? Work done is minus 100. And everything is in millijoules only, no? So no problem. So therefore, now if you do this calculation, okay, see how much I will get. So 50 is equals to 400 minus UB minus 100. Okay, ma? So UB value is how much, ma? It is 300 minus 50. It is 250 millijoules. Okay. So what is the internal energy at point B? Internal energy at point is 250 millijoules. Whereas internal energy at point C is 400 millijoules. Is it clear? So by using which logic we have done this problem? By using the first law of thermodynamics. Q is equals to delta U plus delta W. Clear, Nama? That's it. So therefore internal energy at point C, here I am writing how much it is? 400. Clear, Nama? Millijoules. And internal energy at point B is how much? Internal energy at point B is 250 millijoules. Understood, no? Now try to do the calculation of second question. Come on. So Sima, we will do the second question. So find the work done by the system and heat supplied to it when it is taken from state C to state B. But by which path? Via CDAB path. Okay. It means if you travel in this path, then what is the amount of work done in this total process? It means this total I am considering to be one process. Clear, Nama? And similarly, what is the amount of heat energy which is supplied in this process? These two I am supposed to calculate. Okay. Now let us see. Sima. So first of all, how to calculate work done? Work done is nothing but area under PV graph. That's all, no? If you take area under PV graph, that is nothing but work done. So this is the total area under PV graph, Nama. So which area? So this total area. This total area is called the area under CDAB graph, including this graph also. This total is the area, no? So if you calculate this total area, you will get the work done. Or you can do one thing. Or what you can do, first calculate what is the work done under CD. Then you calculate what is the work done under AD. Then you calculate what is the work done under AB. Like this also you can do. Okay. First of all, let us calculate individually, then we will see. Okay. So first of all, work done is nothing but area under which graph? CD graph plus area under which graph? DA graph plus area under AB graph. This is how I can do, Nama. If you add all of them, I will get the total graph. Okay. Now let us see. So work done from C to D. First I will calculate this one. That is nothing but area under the graph. Sima, in between C and D, is there any area? No area. It means work is not done. That is the meaning of this one. No? So under CD graph, area is how much? Area is 0. There is no area. Therefore, work done is also 0. Is it clear? Very careful. So can you say why work done is 0 in between CD graph? Volume is a constant. Volume is a constant. No? If volume is a constant, it means gas is not expanding, gas is not compressing. If gas is not expanding, gas is not doing any work. If gas is not compressing, then also gas is not doing any work. So why work done is 0? Because volume is a constant. Understood? So that is why work done under CD graph is 0. Clear? Next you take AD graph. Work done under AD graph. It is nothing but area under DA graph. DA na AD nama DA. Work done under DA graph. Okay. Now see. So D, it is at a lower volume. A, it is at a higher volume. It means work done by the system is positive or negative? Definitely positive, because it is expansion. No? So work done is positive. Okay. And how much is the work done? Area under the graph. Okay. Now see, this pressure is how much? 6. Change in volume is how much? Change in volume is 50 minus 20. So it is how much? 30. 30 multiplied by, and it is liters number, so I will convert into meter cube, 10 power minus 3 meter cube. Are you able to understand? I can write plus 180 millijoules of energy. That is the work done from A to D. Are you able to understand? So next I will calculate area under AB graph. Work done under AB graph. Clear now? So this work done is positive or negative? We are moving from 50 to 70. Expansion or compression? Expansion only. This is also positive. మీరు గ్రాఫ్ ను చూసి కదా చెప్పాల్సింది. వాల్యూమ్ ఈజ్ ఇట్ ఇంక్రీజింగ్ ఆర్ డిక్రీజింగ్? దట్స్ వాట్ వీ హ్యావ్ టు సీ. అట్ ఏ వాల్యూమ్ ఈజ్ 50, no? At B వాల్యూమ్ ఈజ్ 70, so definitely expansion. Clear nama? So therefore I will say work done under AD graph, this is also positive. Is it clear? And how much is the volume? Calculate the area. See, up to here it is a triangle, no? And from here it is a rectangle. So therefore what is the total area? Area is nothing but area of triangle plus area of rectangle. Total area I have to take, no? Area of rectangle. Is it clear, ma? So what is the area of the triangle? Half base into height. So what is the base of this triangle? 70. 20, no? 70 minus 50 is 20. 20 into 10 power minus 3. Plus area under, half into base into height. Height is how much? So height I will take only from here to here, ma. Because this is the triangle which I am taking, no? Only this height I will take. What is that height? 6 minus 2. 6 minus 2 is 4. 4 multiplied by nothing, because it is given in SI units only, so no problem. So therefore 2 ones are 2 2s are. So work done is how much? So I will calculate triangle also, no? Rectangle also I have to calculate, no? So this is again how much? 20, and this is 2. So 2 into 20 into 10 power minus 3. So what is the total work done? So 40 plus 40 multiplied by 10 power minus 3. So work done is how much? 80 millijoules of work done. From where to where? From A to D. Okay. So I have calculated A to B, no? A to B. I have calculated work done under all the 3 graphs, no? So therefore what is the total work done? Total work done from CDAB is how much? This is equals to W1 plus W2 plus W3. W1 0. This one is 0, no? So work done under second graph. This is AD na, AB na, ma? AB, no? I have done mistake here. AB. Work done under DA graph 180. Okay. Work done under AB graph 80. So total how much? 260 millijoules of energy. Millijoules of work done. So I got work done, no? Are you able to understand? So we have done individually work done under each process. Or you can do one thing. You just calculate total area under this graph. Then also you will get the same answer. Okay, ma? So for this you need to divide the figure like this. Okay, like this. So this is one rectangle. This is one triangle. Another rectangle. Another triangle. Like this also you can do. Are you able to understand? Just for your understanding, I have done area under each graph individually. C to B in this process. Why you should not take? This graph we have not considered now. B to C we have not taken, no? So only this graph is present, this graph is not there. Clear, no? Therefore I have to take total area under the graph. Is it clear, ma? Okay. So therefore total work done I have calculated, ma. And from C to B, change in internal energy I know, no? What is the change in internal energy? Change in internal energy is final internal energy UB minus internal energy UC. I am moving from C to B only, no? Final is B, initial is C. So therefore, internal energy at point B, 250. Internal energy at point C, 400. So total how much? Minus 150 millijoules is the change in internal energy. It means what is happening to the internal energy, increasing or decreasing? Decreasing. So temperature is increasing or decreasing? Decreasing, because if internal energy reduces, temperature also reduces. Okay, ma? So therefore, work done I have calculated, internal energy also I have got. So therefore, can't I calculate heat supplied, ma? What is the formula for heat supplied? First law of thermodynamics. What is the first law of thermodynamics? So first law of thermodynamics says that, okay, so first law of thermodynamics, okay, so Q is equals to delta U plus delta W. Q while delta U is how much? Minus 150. Delta W is how much? Plus 260. Plus 260 only, no? So therefore, heat supplied is how much, ma? 110 millijoules of heat energy. So this is the amount of heat energy I have supplied in traveling from CDA to finally B. This is how we have done the calculation. Have you understood, ma? Very simple calculation. Just you should understand sign conventions carefully. If you understand the sign conventions, very easily you can do these calculations. Okay.